So after I did my last two videos, I've decided that they're pretty hard to follow because a lot of people don't really understand how a snowboard is made. And this is fine, that no fault on them. It's a pretty niche thing to know. But I've put together this little animation that'll hopefully clear things up and hopefully allow everyone to enjoy my time lapses a little more because they actually know what I'm doing. So all a snowboard really is, it's just a big sandwich. The technical term is lamination, but these 5 layers are just glued together with epoxy, and while the epoxy is still wet, it goes into a press that bends the tips up, and it dries like that and then holds that side profile, which looks like this. So from the bottom to the top, the layers are the base, fiberglass, the core, and then there's another layer of fiberglass, and then the top sheet. First, we're going to talk about the base. The main part of the base layer is the plastic. This part is pretty simple. It's just a sheet of plastic about 1.5 millimeter thick that gets cut to the shape of the snowboard. What gets a lot of people confused, though, is the steel edges that wrap around the plastic. These edges are important because this is what really digs into the snow and allows the board to turn when you're on the slopes. It also acts as a guide for a blade to cut off excess material after the board is all pressed together. So it's really important to get these edges exactly where they need to go. Anyway, once the edges are bent, they are temporarily attached with super glue. What really holds them on the board, though, is the epoxy that fills these teeth and bonds them to the fiberglass that goes on top of it. The part that you actually see and use to turn has no teeth, and it's just a smooth transition from plastic to steel on the bottom. So on top of the base layer goes a layer of fiberglass. My model doesn't really look like it, so I'll put some pictures up of what the fiberglass mat really looks like. But essentially all it is a mat of glass fibers that are woven together. And these fibers, while dry, are very, loose and flimsy. But when you put epoxy with it, it gets really strong. So on top of the layer of fiberglass goes a wooden core. This core gives the board most of its mass, and it also dampens vibrations when you ride. So it's really important because while it gives a lot of the strength in the board, that mostly goes to the fiberglass. It's more to reduce chatter when you ride. So the other things that are important about it is the inserts. They're just little threaded T-nuts that go all the way through the core that you screw your bindings into in order to ride. Another important feature about the core are these plastic sidewalls that wrap around the wood part. These sidewalls are important because they keep out moisture from the wood, and they also just provide the sides of the snowboard with a lot of protection. This snowboard build is actually my first time ever using these sidewalls. So on my last 2 builds and videos, I just completely left these out. So I had exposed wood on the sides. And after a couple days of me just stepping into the snow with my snowboard, that wood just split right open. So adding these was definitely a big step for me. So on top of the core goes another layer of fiberglass. This fiberglass layer is no different than the first fiberglass layer. You just have 2 for extra strength. And then on top of the fiberglass goes a sheet of plastic that's called the top sheet. So the top sheet is there for moisture protection on the top of the snowboard, and it's also there to have a graphic on it. A lot of people think this art is just a sticker that you just stick right on there, but the art is actually printed into the plastic so that if you could scratch the plastic, the color is all the way throughout. And so again, all of these layers get epoxied together and put into a press to dry where it's all bent up into its shape. I'm going to organize this video by the layers bottom up. So the next thing I'm going to go into is how I made the base. I'm not going to show anything with the fiberglass until I lay up the board, which is putting the epoxy on. And that's because I just buy the fiberglass off of a snowboard shop. And then I'll go to the core, and then I'll show how I designed the art for the top sheet, and then I'll put them all together and finish up the board in the end. So the first thing I need to do in order to make my base layer is cut out a template. I'm just using an MDF sheet. There's really not much to this. I just took my 3D model that I designed earlier and got a 1-to-1 printed version of it, and I'm just cutting out the wood as close to the lines as I possibly can. I'm leaving a little bit of room for myself to sand off later, so I don't make it too small just on the bandsaw. And so here I am just sanding it off. I'm using the drill press with a sanding bit just to shave off wood close to the line. This takes a while and it's pretty boring, so I'm going to speed it up here for you. So once I'm done sanding, I need to drill in the guide holes for my inserts. So this doesn't directly apply to the base, it actually helps make the core, but I use this template for the core too. So this helps me line up where to drill the holes into the actual core. So that's why I'm doing this step. So once I finish the template, it's time to cut it out. First, I'm going to start by roughly cutting the plastic with some scissors. This is just to get those little clamps you see me clamping the plastic to the template. If I don't cut it out with scissors, it doesn't reach the template. How I actually cut it out is using this router here that has a flush trim bit on it, and all that is a little bearing runs along the template, and on top of the bearing is spinning blades that cuts the plastic. So it transfers the template shape directly onto the plastic. And this makes it super easy to cut the plastic to the shape I want. I just need to get the template to the shape I want. And as I route that out, it melts the plastic and causes the plastic to keep these little flimsy shavings on it. So I just had to go around and cut those off with a razor blade. So the next step is to bend the metal edges around. I have two tools that I've made in the past to do this, make it easier on myself. It's very hard to do by hand. I'll put a little clip showing how these work. The main one I use works. It's a metal pipe bender that I modified just by cutting a little groove in it so that the teeth can fit in. The video I'll show will explain it all. But yeah, so if you see, I found that over bending and then bending it back by hand is a very good method. It's taken me a lot of practice to get good at this. You know, it's my 5th board, I think, and on my first 3 or so, yeah, I was terrible at this. Like, there's huge gaps in between the metal edge and the plastic, but this one turned out really well. Very pleased with it. So after I'm done bending it and checking to make sure that I get that edge as close as I can, I'm going to go back, try and clean it a little bit so that the super glue I put on holds well. So now you see me going and just dabbing little super glue every couple teeth. And this super glue is only a temporary hold, as I said earlier in the animation. It's just holding the edge on there close until I lay up the board and put all the epoxy on. Here I'm just doing the other side of the board. This edge is no different than the other one, so I'm just going to speed it up real quick. So most boards have tips that just curve nicely into each other, and so you would bend the edge all the way to the very tip of the board. But on mine, I have these really sharp corners at the tip, so I'm breaking down my edges into 4 different pieces that all just butt up smoothly to each other. So as you can see on the picture to the right, that's my finished product of the base. The part that you see will not be seen in the board. That's going to get covered with fiberglass. So next up is the core. First step is to rip down a bunch of stringers to glue back up into a flat board. This process is called vertical lamination. If you want to look it up, it's very common in longboards and snowboards and skis, obviously. Essentially, you're just aligning the wood grain to be the most strong. That's really all I understand about it. I'm sure there's a better explanation out there. So after I get all those stringers cut, I'm just going to glue them up. Nothing really to show here, so I'll speed this right up. So after I get it all glued up, it's all really rough, so I just need to smooth it down and make it all flat. So once I get the core all flattened out, I need to shrink the template that I made for the base. I need to do this in order to make room for those plastic sidewalls. So if I don't shrink the template, then I attach the plastic sidewalls to the same size that the base is, those plastic sidewalls are just gonna get cut off and not ever used when I lay the board all up. So that's why I'm shrinking the template to get the plastic sidewalls in there. So I'm gonna use this shrank template in order to cut out the core shape. So after I cut out the template, I realized I made a mistake. I shrank the template way too much. So I ended up with this really hillbilly fix where I cut really thin strips of this particle board that was like 2 millimeters thick and just taped it right on the edges to make it whiter. So yeah, I thought that was kind of funny. And here I am taping the template to the core. So my original plan for these sidewalls was to actually pour the plastic into a trench that I route into the core. So here I am trenching out that core. So it's just making a little trench, and then I'm going to pour in a polyurethane plastic that would solidify into the plastic sidewalls. And I really wanted this to work because the trench turned out great. I was so excited for it, but the polyurethane resin that I bought, I can never get to work. I needed a vacuum chamber. I ended up making a really hillbilly one for like $50. That didn't work. It always just foamed up like a marshmallow. So I ended up just biting the bullet and cutting off that trench using a flush trim router bit to remove excess material and just epoxied on the plastic sidewalls. So that's what I'm doing here. I found out that I could bend the plastic sidewalls around the core. This made it so much easier than the last time I tried it, which I never finished that board actually. But yeah, I just bent it right on the edge of the table, and that allowed me to butt up the plastic with the wood. And then here I'm just gonna set it on its side and epoxy. So this job was actually a lot more difficult than I thought. Mostly because I didn't cut out the core very well, so there's a lot of waves and holes that the epoxy was struggling to reach and fill. So I actually had to go back and refill those holes after the first coat had dried. So this step I really finagled with. It was really just flying by the seat of my pants, really. Just filling holes, fixing mistakes as I went. After I got the sidewalls attached, I am going and smoothing it out again because the epoxy obviously makes it all rough again, and I'm going to thin it out to its final thickness in the center. So I'm shooting for 7 millimeters thick here, and as I'm doing this, I pop off the sidewall again. So it came off, and here I am super gluing it back on, and this is kind of funny. I mean, not at the time, kind of hurt, but I slowed it down here because as I'm going, I snap the super glue into my eye there. So you see my hand go to my eye. It's because I accidentally squirted super glue into my eye, and that was a day before my open house, and we also didn't have any water in the house. So yeah, it was a big fiasco right there. So anyway, once I got the core to the correct thickness, I'm going and adding a rabbet. So this is just a little trench around the edge that holds the tang. So if I don't have this recess in the wood, the tang on the edge would actually bend the base layer into a concave bottom. And after I do that, I am drilling out the holes for the inserts. I used the template from earlier to transfer those little guide holes onto the core, and I just line up the bigger bit with that small little hole, drill in a little bit, flip it over, and drill the other way, and that just reduces tear out. So after I drilled those insert holes, I'm going to thin down the nose and tail, just using the router sled and a sander. I just gradually lower that bit as I go down the tip. And the hard thing about this was not ripping those sidewalls off. You see that I did it right there pretty badly. I actually broke the sidewall completely. I'll put a picture up and I'll show how I fixed that. I just cut another piece of sidewall really small to fill that gap and then epoxied it all in. So once I made that mistake, I changed my procedure a little bit. I added this blue tape to the bottom of the sidewall and the core. I don't think that really did anything, but what I did do is I started cutting into the core rather than just going all the way through with the router. I decided that was just tearing at the sidewall and pulling it off the wood. So I made sure that I would enter the core from every side before I actually made a full pass. And I just babied it. I took as little as material off as I could each pass. After I got the tips tapered down, I super glued in those inserts into those holes I drilled earlier, and that's a finished core. So the last layer of the board is the top sheet. I'm putting it towards the end of the video because it's the top of the board, obviously, but I actually designed this before I even started anything else. But my inspiration for this artwork came from something my pastor always says in church, which is that we live in a broken world. And I really like that idea, so I made this shattered earth design. I like the idea a lot, but I just thought it was too simple for a board. So that's when I came up with another idea that was this twin mountain thing. And I really like this too, but I also thought it was too simple. So that's when I just put them all together, and I ended up with this all shattered mosaic-y twin mountain idea. So that's where my inspiration comes from. I'll put the progression of work as I went on, just tweaking little things here and there. But yeah, I'm really happy with this design, and I think it looks sick. And another thing I should say is I didn't paint this on the top or anything. I paid a company called Marhar Snowboard to actually print this design that I sent them onto a top sheet. So this is the final piece. I'm really proud of it, actually. So once I have all the layers done, I just need to epoxy them all together and throw it in the press. So here I am just spreading the epoxy out. You're going to see me add this little rubber strip to the edges. That's called VDS rubber, and it improves the bond between the metal and epoxy. My last couple boards I made, I had delamination on my edges, and I think it's because I didn't do this step. So as you can see, that fiberglass gets really soaked with that epoxy, and it gets real strong, as I was talking about earlier on in the video. And so yeah, you just sandwich the board up, and then you put it in the press that I have there in the background. That press is the same press I used on my last board, and I just modified it a little bit so that the tips bend up higher. So after letting the epoxy cure for a couple days in the press, the board is there. I just have to go in and find it pretty much. So I use this foam to decrease the imperfections in the press transferring into the board. I made a board where I didn't use this foam, and it just came out all wrinkly and gross. So that's why I'm ripping this foam off like a heathen. And then the next step is to do what is called deflashing. So the fiberglass runs over the base material, or the real shape. And in order to get this off, you just follow the metal edge with the bandsaw or a jigsaw, cutting off that excess material. And that's where you find the board. And that's why bending the edges and getting the shape perfect on the base is so important, because the base shape is the final shape, because that's what you follow to create the final product, right? So after I deflash the snowboard, I need to go and sand down those sides to clean up that cut. It's a bandsaw. It's a curved surface on a flat table. It's not perfect when I get it out of the bandsaw, so I'm sanding it down to the edges. I pretty much go sand plastic, and once I touch metal and I start getting sparks coming off the sander, that's when I stop. Also, the other thing I'm doing with the sander is I'm beveling that side. So, or I guess it might be called a chamfer. I don't really know. But I'm doing this with a belt sander, doing it by hand, doing it by feel. But I see people, I think the best way to do it is with a router and a flush trim bit that is like put at an angle, specified angle that you want. I've done this before. I get weird marks on my snowboard, so I just find it's better to do it, or I like to do it better by feel. The other thing is, though, is I didn't really feel like I had a lot of room to work with my sidewalls, so I kept this angle very vertical, very close, very much closer to perpendicular to the ground, because I was afraid of sanding all the way through the sidewall material and hitting the wood. Whether or not my concern is unfounded, I don't really know, but I decided that I would rather not ruin my snowboard than find out. So then the next thing is to draw out the inserts. I'm using metal dust to find them, because on the inserts I have, there's a little magnet in there. So you drop the dust, the magnet attracts the dust, and that tells you where the insert is, and that tells you where to drill. And now is the time where I am done. All I have to do is pull off this protective covering of my top sheet, see those colors pop, feel rewarded for all my hard work. It was so nice doing this. So this is the final product. I'm very happy with it. There's some things I would change, but that's what I do it for. It's a learning process. Thanks for watching. If you have any questions or just want to talk about this at all, feel free to contact me, and I guess just have a good day.